Hi everyone, today we're going to talk about reference angles, what they mean, what they are, and how we can go about finding trig functions of any angle. So the stuff you see on your screen follows exactly along with your note sheet, so you can copy all the notes down so you have that to reference when you're working on your assignment. But here's the idea. Way back when I was in school, when I was your age, we didn't have graphing calculators, we didn't have these fancy dancy things to find stuff for us. They just weren't in existence. What we did have were tables. They were trig tables. It was in the back of our textbook, and it literally was just a table of all of the trig values. And you'd have to leaf through it to find if you wanted like the sine of 35 degrees, and you'd have to go to the back and find that in the table. Problem was, this trig tables only went up to 90 degrees. And so it didn't really allow us any means to deal with functions or angles that were greater than 90 degrees. And so this whole idea of reference angles, it was used, and we still use it today. And what it does, it is a reference angle refers you back to a first quadrant angle. And that's the idea behind it. And now I know that you can always plug anything you want into a calculator nowadays, but this is going to be really helpful when we're doing some other problems as we get farther along into trig. So here's the idea. We can find any trig value of any function simply by asking ourselves the three questions that you see on the screen. The first question will be, well, what quadrant is the angle in? Meaning, what quadrant does this terminal side end in? That tells you the quadrant the angle is in. We talked about that before. Is the trig value positive or negative in that quadrant? And then how far is it from the x-axis? And this right here is the most important part of that. I'm going to explain all this. We'll go through some examples so you can understand what it is that I mean. But first, let's just do a quick review. Remember, we said that all of our trig functions, right, are positive in the first quadrant, only sine is positive in the second, only tangent is positive in the third, and only cosine is positive in the fourth. And remember, the reciprocal trig functions follow along with these. So cosecant would be positive where sine is positive, cotangent where tangent is positive, and secant where cosine is positive. And what I mean by this is where the whole idea of the reference angle comes from. And I'm going to show you in the next example what I mean and how we go about finding that. Okay, but these are the three questions in this order that you want to ask yourself whenever you're doing these types of problems. I promise you it gets easy. It almost becomes, I shouldn't even say almost, it does become automatic once you do it a few times. Just ask yourself those three questions and you'll get the right answer every time. So let me show you what I mean. We have the cosine of 130. Okay, so I like to draw myself a quick little picture. Okay, so 130 is in the second quadrant. That was the first question. Okay, so I'm going to draw just a second quadrant angle. Okay, it doesn't need to be exact, but just to get an idea, right? That's my second quadrant angle. That's 130 degrees. And you don't have to write in the 130, but for the first few problems it might be helpful to do that. Okay, is cosine positive or negative in the second quadrant? Well, cosine is negative in the second quadrant. Okay, so now I know that my answer should have a negative in it. So my answer is going to be negative cosine of some angle. This angle needs to be the acute angle. This is where that third question comes from. What is our reference angle? How far are we from the x-axis? So I want this distance right here. This is how far I am from the x-axis. If this is 130 degrees, remember all the way over to here is 180 degrees. So this reference angle would be 50. So my answer here is just negative cosine of 50 degrees. That's the answer that I'm looking for. And let me show you on a calculator that we actually, those two things mean the same thing. Okay, so if I do the cosine, let me clear that out. Clear. If I do the cosine of 130, that was our original problem. we end up with negative 0.642 blah, 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 right? Now I'm going to put this in my calculator. I'm going to put in negative cosine of 50. And when I put that in, notice I get the exact same answer. Okay, so that's the idea behind what we're going to do with all of these, and that's what I mean by reference angle, how far you are from the x-axis. So let me go back to this for a second. When you are in the second quadrant, so when you have a second quadrant angle, okay, this is the angle that you're looking for. This is your reference angle. So I'm just going to write reference theta. That's your reference angle when you are in the second quadrant. Okay, if you have a third quadrant angle, I'll just change colors here. If you're in the third quadrant, here is your reference angle. That's how far you are from the x-axis. We're always going from the x-axis. Okay, and if you are in the fourth quadrant, this right here is your reference angle. That's how far you are from the x-axis. Remember, this doesn't apply at all in the first quadrant because those are already acute angles. Okay, so that's the idea. We'll do a bunch more of examples here. The next example is the sine of 196. So here is my picture. 196 is in the third quadrant. Okay, and so first, that's the first part. Third quadrant, is sine positive or negative in the third quadrant? Remember our little cheat here, ASTC. Sine is negative in the third quadrant. So I'm going to put negative sine. And then what is my angle? What is my reference angle? So how far am I from the x-axis? Well, remember, this is 180 degrees. So at 196, I'm just 16 degrees away. So the sine of 196 is equal to negative sine of 16 degrees. Okay, now notice here, this was a second quadrant angle, and 130 was a second quadrant angle, and my reference angle was positive. Here, 196 is a third quadrant angle, and my reference angle is also positive. We always want that reference angle to be positive. Okay, so depending on which quadrant you're in, if you're in the second quadrant, you're going to do 180 minus the angle that you're given. If you're in the third quadrant, you're going to do the angle minus 180. So you can go back and put that on your picture if you want. If you're in the second quadrant here, your reference angle is going to be 180 minus whatever the angle you're given is. When you're in the third quadrant, you're doing the angle minus 180. So that angle always comes out positive. Okay, and in the fourth quadrant, you would do 360 minus theta. That says 360 minus theta there. So that's how you go about, finding those reference angles. Okay, let me go back. We'll do a couple more examples. Here I have the tangent of 263. So go through your questions. 263 is in the third quadrant. Tangent is positive in the third quadrant, so I still have a positive here. Positive tan. How far am I from the x-axis? If you do 260 minus 180, that would give you 83 degrees. Okay, in problem number 4, here a lot of times you'll see this angle in parentheses, sometimes you won't, but it's the same thing. And now we're talking about a negative angle, right? We have negative degrees here. So let's use a coterminal angle to figure out where that puts us. Okay, so if I add 360 to that, if I add 360, right, then I have the cosine of 8 degrees, right? If I end up with negative 8 degrees, right? If I add 360 to that. So I still have a negative angle, but if I add 360 to that again, I end up with 352 degrees. Okay, so now I can say, all right, well, that's a fourth quadrant angle, right? Fourth quadrant angle. cosine is negative in the fourth quadrant. And my reference angle, how far am I from the x-axis? Well, I'm only 8 degrees away from the x-axis because I'm doing 360 minus 352. And that would be my answer. So sometimes you have to use coterminal angles to get it to be an angle between 0 and 360 before you can figure out what that reference angle is. Okay, I'm going to stop this video here. I'll put the next set of problems in another video. The next ones we're just going to take it an additional step where we're finding the exact value. Thanks, folks.